project using this Arduino microcontroller to turn on and off this DC motor pan. And we're going to use this Arduino microcontroller and uploading the code for our project. Our project, we have the Arduino Uno. We are done with uploading the code, so we are using 9 volts as supply to the Arduino Uno microcontroller, and then we have this DC motor pan and the sensor, ultrasonic sensor. Also with with 7805 voltage step down voltage regulator from 9 volts step down to 5 volts. We are using this ultrasonic sensor as a switch to the DC motor pan. Now, let us do that by covering when there is an obstacle or anything in front of the sensor, it will turn on the DC motor pan. How about this one? If we have this lighter, if there's an obstacle or any hard surface, it will turn on the motor pan. So the ultrasonic sensor serves as a switch, automatic switch to the DC motor pan or to our electric pan. We have the figure 1 DC motor control using ultrasonic sensor HC-SR04. Where is that? Okay, let us see the sensor. This is the sensor HC-SR04. What is this kind of sensor? What kind of sensor is this? This is, so if this is the sensor, we have 2 eyes for the trigger and echo. Trigger pin and echo. Trigger pin always emits sound waves. And then when there is an obstruction or any hard surface, it will bounce back to the echo. And then it will go to the out of the Arduino and then to the motor. That is the kind of sensor that we have. Sound waves. Ultrasonic. It means a very high frequency sound waves that we could not hear. We are not unable to hear this kind of sound waves. So it emits a sound. It is just like an echolocation. In the case of bat or the dolphins, throwing a sound waves, and then it bounce back because there is an obstruction, and it will locate to where is the obstruction. It can able to detect the obstruction because of the throwing up or emitting continuous sound waves and then bouncing back. That's why there is an echo. So that is the kind of sensor we have. This sensor, trigger and echo, and it has 5 volts from the Arduino Uno and ground to ground. So this is connected to the ground. Okay. Arduino Uno is powered by this battery, 9 volts. After done uploading, we can able to connect this 9 volts battery to the voltage in of the Arduino. So we have now the 9 volt supply, and we have this power indicator, so that we know that the circuit is powering on using 4.7K and blue LED. So this is power indicator. Why are we using a voltage regulator 7805? What is the purpose of using this regulator? This regulator is a step down from 9 volts, the input, stepping down to 5 volts. Converter, voltage converter, or step down. We're using a capacitor here in the input and to the output, just to stabilize the flow of current or voltage between the input and the output. Stabilizer, and then ground pin 2 of the 7805 voltage, stepping down the voltage from 9 volts to 5 volts. Why do we need to step down the voltage? Because our motor is 5 volts. We cannot use the 5 volts from the Arduino because the motor consumes a lot of current. In our testing, it consumes up to 40 to 60 milliampere. 40 to 60 milliamps. And the voltage, the pin out of Arduino is usually up to 50 milliamps, just like that, or less. So we need an external power supply. In this case, we need 5 volts separate power supply to our motor, because the motor consumes a lot of current hungry. Connected to the one terminal, and then the negative connected to the collector of transistor BC547 NPN type. Why do we need the transistor? Why is it just connect the output to the motor? We need this transistor as a driver to the motor. Why is it that the motor needs a driver? Because this motor consumes a lot of current, and this transistor is capable of handling this type of current, or this current. It can handle up to 100 milliampere. I guess this is 100 milliampere. So this transistor can able to handle the collector current, can able to handle the current of the motor to the collector of the transistor. So we need the transistor as a driver to the motor. And the pin number 8 is the out. So whenever we have this trigger pin of the sensor, this one, and then encounters an obstruction, the reflected waves, sound waves, is being reflected to the echo pin. So this one, echo pin, and then pin number 10 goes to pin number 10, and then to the pin number 8 out of the Arduino to the base of the transistor, causing this transistor to switch on because there is now a triggering current from the pin number 8, the out pin out of the Arduino, because of the sensor, causing the current to flow here, and then it will produce a 0.7 volts, enough to switch on this transistor base to emitter, at least 0.7 volts. So it will switch on this, therefore the current flows into the motor, causing the motor to turn on. Why is it turning on? Because of the obstruction. If there's no obstruction, it will not turn on the motor. So we need this whenever it encounters an obstruction, this two sensor reflecting there is a reflected waves, and then it will trigger the transistor, causing the motor to spin or to rotate or to move. So in short, because of the continuous emitting of sound waves of the trigger pin of this ultrasonic sensor, and the obstruction, because there is an obstruction, reflected waves flowing back to the echo pin and then to the Arduino, then flowing out to pin number 8 of the Arduino, then triggering the transistor, turning on this motor. That is why that makes the motor to rotate. That is the reason why the motor is rotating or moving, because of the sensor, the obstruction.